Hello and welcome to our lesson 4.7. We are here on page 165, and today we are going to be looking at patterns on the multiplication table. Our essential question: how can you use properties to explain patterns on the multiplication table? And we're really going to be looking a lot at patterns today. So things like patterns you might know, like red, blue, or patterns like short, tall, or patterns like 2, 4, 6, 8, number patterns, how patterns change and grow. So we'll be thinking a lot about that. Let's go ahead, follow down here. We're on page 165 still, and we're going to unlock the problem. So you can use a multiplication table to explore number patterns. Activity 1. We're going to use this math board. Now, sometimes memorizing multiplication facts can feel a little overwhelming. So today we're going to look at a multiplication board or a multiplication chart, and it will hopefully help us see some of the patterns and how some of the math properties that we know, like the commutative property where you can turn things around. 2 times 4 is the same as 4 times 2. How that works, we'll be able to see that on this board. We'll be able to see how we'll also take a look at the distributive property, and let's just jump in and take a look. So it says write the products. Remember, products are the answers. I want you to write the word answer there. So products are the answers. Write the products for the green squares. What do you notice about the products? Now the way this chart works is the numbers on the up and down and the numbers on the left to right, this column and this row, these are factors. These are the numbers we are multiplying together. So go ahead and do write factors, just so you remember that that's what they're called. And we're going to fill in the green the green products. Everything on the inside here, all the things on the inside of these squares, these are called the products, the answers to the multiplication problem. Okay, so the green squares. So 8 times 0, any number times 0 is 0. And then 8, oh no, sorry, I'm filling in the green. So 7 times 1, any number times 1 is itself. 7 times 1 is 7. Now we're going to do green, so 6 times 2. We're just doubling 6, right? That's 12. And here we go for this green square. We're going to do 5 times 3. 5, 10, 15 is 15. And then for this green square, we're going to do 4 times 4. 4, 8, 12, 16. Okay, 16. Rolling my numbers helps. My 4s, I get a lot of help from rolling my numbers. Now here we go, this green square. 3 times 5. 3, 6, 9, 12, 15. So 15. And then this green square is for 2 times 6. 2 times 6. So 2, 4, 6, 8, 10, 12. 2 times 6 is 12. For this green square, we're going to do 1 times 7. Well, 1 7 times is the same as 7. And then for this last green square, a 0 times 8. 0 8 times is still 0. Okay, so now what do we notice about the products? Let's take a look. Let's see, we've got 0, 7, 12, 15, 16, 15, 12, 7, 0. Oh, what do you notice? From here, if we go out, we've got 2 15s. We've got 2 12s. We've got 2 7s. We've got 2 zeros. So this 0 was for 8 times 0. This 0 was for 0 times 8. I noticed 8 times 0 equals 0. And 0 times 8 equals 0, right? This 7 was 7 times 1 equals 7, but 1 times 7 equals 7. So 7 times 1 equals 7, which 7 equals 1 times 7. So these are showing us the factors are turning around, but the products are staying the same. Does that work with 5 times 3? And 3 times 5? Yes. So change my color pen so it's a little easier to differentiate. But when the factors change order, the products stay the same. Okay? And that is our commutative property. I like to call it the turnaround fact, but it is, the formal name is commutative property. All right, so we'll write the multiplication sentences for the products on our math board. And what do we notice about the factors? That's kind of what we wrote here, right? We wrote some of these factors already, some of these products. Let's write a few more. So if we did 5 times 3 equals a 15. And for this one, the 3 times 5 equals 15. I'll write them as totally separate ones. I may have confused you by putting the same product in the middle and kind of flip-flopping them a little. But you can see 5 times 3 equals 15. Oh, and as I read again, I messed up, Mrs. Findlay. It's so great when you make a mistake on a video, right? It's there forever. So that's what we notice, right? We notice that commutative property. So do you think this will be true when we get to the yellow squares? Let's take a look at the yellow squares. Let's try to fill those in. And I'm going to use blue for those. Let's see. All right, so 6, if we're going to fill out this yellow square, 6 times 0 is 0 so far. Now we've got for this yellow square, 5 times 1 is 5. Now for this yellow square, 4 times 2 is 8. For this yellow square, we've got 3 times 3, 3, 6, 9 is 9. For this yellow square, 2 times 4, 2 4 times, 2, 4, 6, 8 is 8. For this yellow square, we've got 1 times 5, 1 5 times, 1, 2, 3, 4, 5 is 5. And for this yellow square, we've got 0 times 6. 0 6 times. 0, 0, 0, 0, 0, and 0 for 6 times. It's 0. So did that work? Right? It is, right? We've got, let's try for this one. 4 times 2 equals 8. And this one, it's 2 times 4. So this is the commutative property. And I'm going to put its nickname. I'm going to put turnaround fact. You can write turnaround fact too. It just helps me visualize it, that those factors are turning around, right? All right. Now it says, well, I am always jumping a little ahead. Even though I look at this ahead of time, I think I want to skip things. So here it says, we're going to write the products for the yellow squares. Boom, we're done. Now complete the columns for 1, 5, and 6. The columns for 1, 5, and 6. Okay, are you ready? Let's do those columns. I'll do them in green. So 0 times 1 is 0. 1 times 1, 1 time is 1. 2 times 1 is 2. Oh, these are all ones, right? Any number times 1 will be that number. So 3 times 1 is 3. 4 times 1 is 4. That worked. 5 times 1 is 5. 6 times 1 is 6. 7 times 1 is 7. 8 times 1, you can see this is growing. This pattern is growing by ones. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That works, right? 10 times 1 is 10. All right. So let's do our fives. 0 times 5 is 0. Any number times 0 is 0. 1 times 5. One group of 5 is 5. 2 times 5. Two groups of 5 is 5, 10. 3 groups of 5, 5, 10, 15. All right. 4 groups of 5, counting by 5s 4 times. 5, 10, 15, 20. So we can see how this pattern grows, right? 0, 5, 10, 15, 20. 5 times 5 is 25. 30 is 6 times 5. 7 times 5 is 35. So we can keep this pattern growing. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. You could keep going, even grow this chart even bigger, right? All right. Notice in the fives, you've got 0, 5, 0, 5, 0, 5, 0, 5, 0, 5, 0. The ones place is alternating between 0 and 5. All right, now let's do our sixes. 0 times 6, we already know is 6. 1 times 6, any number times 1 is itself, is 6. 2 times 6, 2 sixes is 12, or 6 plus 6 is 12. 3 sixes, 6, 12, 18. This is where I like to roll my numbers and say the little song. 6, 12, 18, 24, 30, 36. And the spider says 42, 48, 54, 60, 42, 48, 54, 60, 66, 72. How do you do? All right. So we filled in those products on our chart. And what do we notice? Look across each row and compare the products. So we're going to look across each row. Let's look here in the tens. I'm going to zoom in a little bit. And let's just look at the tens and go across the row. So if we're going 10, 50, 60, counting by tens. 9, 45, 54. Let's try our sixes. We have a lot of sixes filled in, right? 6, 12, 30, 36. If we filled in this whole row of sixes, I bet it would be the same, right? And we know that that turnaround fact would work. So this is, if this 30 here, we've got 6 times 5 is 30. Oh, wait, 5 times 6 is 30. Check that out. Whoa, I didn't see that at first. Look at that. I'm going to kind of highlight this. 30 and 30. See the same? It's the same product, but we've got different factors. 6 times 5 gave us this 30, and 5 times 6 gave us this 30. Wow. So those turnaround facts, when they're side by side, these two columns are next to each other, we've got those turnaround facts. Do you see that? So let's look across each row. And, wait, but we didn't look at the ones, did we? So that's pretty cool about the turnaround facts. But take a look at this. If I look at, let's look at 2 times 1 is 2. 2 times 5 is 10, but 2 times 6 is 12. What do we notice about that? 2, I'm going to write that out a little bit down here in my notes. If I can get up enough so you can still see it. All right, so 2 times 1 equals 2. 2 times 5 equals 10. And I'm going to put 2 times 6 equals 12 right here. Okay? So take a look. Look at this. If I were to add 1 plus 5, that gives me 6. If I add it. And check out what we have here. 6. Right? Let me zoom that in a little bit so you can see what I'm talking about. From that chart, if I were to add the 1 plus the 5, I get 6. So 2 times 1 is 2. 2 times 5 is 10. 2 times 6 is 12. What if I add 2 plus 10? That gets me, if I add those together, that's 12. Whoa. So I can look at, this is pretty tricky. I can use this chart to help me see that I can kind of break it apart. I could break 2 times 6 apart into 2 times 1 and 2 times 5. Ooh, and we can kind of break things apart and separate them a bit. So it says complete the columns, rows. Look, what do we notice? So we noticed that we did see the turnaround facts first. And I'm going to use the little and sign. We can split up math problems. And that property of the splitting it up, if we want it, if 2 times 6 is a little tough, when we break it up, that is actually called the distributive, where we're distributing it out differently. This name for me is hardest to remember. Distributive property. But whether you know the name or not, it's understanding that concept. So let's take a look one more time. Let's look at one more and see that distributive property. Okay? So let's say, let's try 6. I know we already used that. Let's try 4. All right, so 4, we've got a 4 times 1 is 4, and 4 times 5 is 20. 4 times 6 is 24. So let's 4 times 1 equals 4. 4 times 5 equals 20. If I add that up, right, I could have 4 times 6, which equals 24. Do you see that? That's a tricky way to use this chart and to really reflect on what the chart can show us. But the chart can help us break bigger problems apart into easier ones. So let's say if I wanted to do 9 times 6, but I'm like, oh, that stresses me out. But I feel good about my 5s and I feel good about my 1s. I could do 9 times 1 is 9. And I know 9 times 5 I can figure out is 45. So I could add 9 times 5 and 9 times 1 together to tell me 9 times 6, right? Add 45 plus 9. 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. It worked. All right, we're only doing page 165 for this video. Check out the next video for page 166. Thank you.